Hey everybody, today we're going to look at a couple examples of graphing a few absolute value functions. So absolute value again is our function that makes negative numbers positive, positive numbers negative, excuse me, let's try that again, makes negative numbers positive and takes positive numbers and keeps them positive. And we know that we have a few different ways that we can graph this. So one way we've looked at graphing this is just by using this idea of your parent function, okay? And the parent function, wow, let's try that again. All right, our parent function, okay, looks like this, right? And we can get this by making ordered pairs. We can get this by plugging values in and going from there. What you've seen in your notes and the things that we've done so far is how we can use the transformations of this graph to make it look like it's supposed to using this parent function. So the graph in black is just the function, the absolute value of x. So now what changes when we graph this? Well, if you've seen from your notes and hopefully from some of the other things that we've talked about, you know that your equation for absolute value with your transformations looks like this. So whatever number we are subtracting from the inside of your equation is the amount we're going to move our graph. So in this case, it's 4, so we're going to move it 4 to the right. And again, how can we tell left or right? I always think of it as what number inside your equation makes this equal 0. In this case, it would be positive 4. So that's going to move your graph 4 to the right. Now, do we have any other adjustments? Does anything change in your slope or your steepness? Nope. There's nothing over here to move it up or down. So from here, we can graph our function. We know absolute value, up 1 over 1, up 1 over 1, up 1 over 1. And then this works in both directions because absolute value is symmetrical. Okay? Now, could I confirm my answer? We could if we wanted to do like an XY chart or an X f of x chart. So if I were to plug in 4, I would get out 0. If I were to plug in something like 6, again, you can just choose whatever you want. 6 minus 4 would be 2. Absolute value of 2 is 2. Okay, maybe I choose something on the other side, like 2. Well, 2 minus 4 would be negative 2, but absolute value of negative 2 is positive 2. And sure enough, if you look at those points that we graphed, 4, 0, 6, 2, 2, 2, they match our graph, so we know we've done it correctly. Let's try one more example here. Okay, so again, we know our parent function, or the regular graph of absolute value of x looks something like this. Okay, goes through 0, 0, and then up 1 over 1. Okay, so now what we have here is we have an a value, so this means we're going to be 2 times steeper. Okay, and then the 2 at the end here means we're going to move it up 2. All right, so we're going to start with the up 2. So it's going to take this point here and move it up 1, 2. So I'm going to be at 0, 2 is my starting point. Now absolute value, of course, normally goes up 1 over 1, up 1 over 1, okay? But here it's going to be twice as steep, so that means we're going to go up 1, 2 over 1. So from my point to my graph here, I'm going to go up 2 over 1. Up 2 over 1. Okay? So half my graph looks like this. And again, we know this is symmetrical. So up 2 over 1. Up 2 over 1. Our absolute value graph would look like this.